In today's educating video, we're going to look at using this whole idea of completing the square and factoring and inequalities, and we're going to pack it all into one nice lesson. And really the first two problems are just reviews of what we did when we had quadratic equations and we needed to solve them. But now we're going to put these equations in some sort of context, and you're going to see why what we've been doing is so important. So if you look here, number one on your in-class assignment states, an object is launched at 19.6 meters per second. So we don't know what this object is. Maybe it's a rocket being shot off into the sky from a 58.8 meter tall platform. The equation for the object's height at time t seconds after launch is S of t, so this S of t represents the final position or the position of whatever this object is that is being shot after t seconds. So that could be 2 seconds, 3 seconds, 4 seconds. It could be many different times that we plug into this equation. But the position is equal to negative 4.9 t squared plus 19.6 t plus 58.8, where S is in meters. When does the object hit the ground? And I gave you a hint. Solve this problem by completing the square. Now, we're actually looking at things in context, and this is extremely important, getting used to working with word problems, because remember, in mathematics, the equations that you get are never just like a pile of numbers. These numbers come from somewhere and have context. And it's important that you know how to communicate these findings and communicate these problems so you don't sound like this. Or possibly even this. Well, that was weird. But anyway, so we want to solve this problem by completing the square. But there is some thought that needs to be put into this problem before we can begin solving by completing the square. So the first thing I'm going to do is I'm just going to rewrite the function that's given. So we've got a function. We've got a function here, S of t. S of t is equal to negative 4.9 t squared. That's supposed to be a t there. T squared plus 19.6 t plus 58.8. Now, let's go back to the very first standard that we covered this semester, interpreting these equations in context. So if I were to ask you, look at the problem, and tell me, what is the constant in this expression? Yeah, so hopefully you were able to say that the constant is going to be the term that does not have a variable. So we look at the first term. This term has a variable t squared. This term has a variable t, but this term, this very last term, does not. Now, if I ask you to identify the constant, you just write 58.8. But if I were to ask you to interpret the 58.8, look back at the problem and tell me, what does 58.8 represent in the context of this problem? Yeah, so hopefully you were able to say that this constant, 58.8, represents the initial position, the starting point of where this object is being launched from. So 58.8 meters is how high off the ground the object is launched. Okay? Now, if I were to ask you, what is the coefficient of t in this problem? What would you say? So if I'm asking for the coefficient of the t term, you don't look at this one because this would be the coefficient of the t squared term. So if we're looking for the coefficient of just the t term, that's going to be this term, and the coefficient in this case is just going to be the 19.6. Okay, the 19.6 here, and I'll underline this one for constant. Maybe I'll just label these here. So C we said was constant, the constant. And we said that the 19.6, so the 19.6 in blue is going to be coefficient, the coefficient of t term, of the t term. Okay, now if I were to ask you, interpret the 19.6 in the context of this problem. Look back at the word problem and tell me what 19.6 is. Yeah, so hopefully you were able to say that the 19.6 is the meters per second, or the initial speed of this object that is being launched. So this object is not being released from rest. It actually has some speed whenever it's launched from either your hand or the cannon or whatever it is that is launching this object. We know that this 19.6 meters per second is going to be, in the context of this problem, it's going to be the initial speed. Okay, so let's solve this problem. Let's solve this problem, but in order to solve this problem, we have to start by interpreting exactly what it's asking us to do. So when does the object hit the ground? Okay, so let's go to the next slide and just draw this situation. We've got, let's say the object is a ball. So let's say the object is a ball. And we know that this ball, it starts at a height of 58.8 meters from the ground. Okay? So 58.8 meters from the ground. So this is measured from the ground. So when this ball is launched and it actually hits the ground, or this object hits the ground, it drops all the way down, and its final position in this case, when it hits here, the position is at 0. Position is 0. Is 0 whenever it hits the ground. So if we go back to our problem, what do you think? If we're looking for the time, or for if we're looking for the time when does the object hit the ground, okay, we want to know what t is equal to when the position, that is s, is equal to 0. So the situation that we have here looks like this. We have 0 for s of t. We have 0 for s of t. And that's going to be equal to negative 4.9 t squared plus 19.6 t plus 58.8. So what this equation is telling us, since we set the s, that is the final position, that is the position when it hits the ground, to 0, we can solve for the time t, and this will tell us how much time it takes the object to actually reach the ground, or that is whenever the position is 0. So let's go to another slide and just rewrite this equation and solve. And I've already rewritten the equation on the next slide, so here we go. And I'm going to leave this picture over here so you can have a nice visual representation of what is happening. So again, let's recap. This equation, since we have plugged in 0, that is the position of s of t, that's this part, whenever the ball hits the ground. And we call that position 0. So if we solve for this, it's going to tell us what the time is, or how much time it takes for this ball to go all the way down and hit the ground. Okay? So that's probably the hardest part, is setting up the equation in the context of this problem. But now look, if the rest of this has confused you, just ignore everything else and just look. Just look at the problem. Now it's just a regular old quadratic that we've been working with for almost a month and a half now. Now let's solve this problem by completing the square. Now I want to be very clear here. We're not trying to write this in vertex form. This is a different problem. We're trying to use completing the square to actually solve this problem. There's a big difference here. You can use completing the square to rewrite this expression or this equation in vertex form, but here we want to use completing the square to solve. And there's a nice step-by-step procedure in class notes 8. And if you can't remember what we do to complete the square to solve quadratic equations, maybe go ahead and go to iTunes U and pull up in class notes 8 and just follow through the step-by-step procedure. So step number one. Okay. What is step number 1 when we want to solve a quadratic equation by completing the square? Yeah, so hopefully you were able to say that step number 1 is put the variable terms on the left-hand side. So these terms that have variables in them, we want to put those on the left-hand side of our equation, and the constant terms on the right-hand side. So remember, we said that this is a constant. This 58.8 is a constant term, so we want to move that to the right-hand side of the equation. So the way that we do that is by first subtracting 58.8 from both sides. Subtract 58, which I'm getting a little cramped there. 58, and then I'll just write it like this, 0.8, and we end up getting negative 4.9 t squared plus 19.6 t is equal to negative 58.8. Now, is this ready? Is our expression ready to complete the square? And the answer is no. We're not ready to complete the square yet. So the answer is no. This is not ready to complete the square. So if you're following along on In-Class Notes 8, Step 2, divide all terms by a. And the reason that we need to divide all terms by a is because we need to have a 1 in front of our squared variable term. So here's our variable that's being squared. We need a 1 out here in front before we can solve by completing the square. So in order to get a 1 out here, hopefully you know by now that we need to divide every term by that coefficient of the squared variable term. So we do negative 4.9, divide by negative 4.9, and then divide by negative 4.9, and we get the first term. Okay, when we do negative 4.9 over negative 4.9, those just cancel out, or give me 1, however you want to think about it, and we get t squared minus, because we've got a plus sign over a minus sign, so positive divided by a negative, that gives me a negative, and 19.6 divided by 4.9, that gives me a nice integer number. So in this case, it's going to be 4. Now, don't forget your t. A lot of you have a bad habit of when you do this operation, when you divide, you forget to carry your variable down. So we need to bring our t down with our 4, bring our t down, and we say that's equal to, we've got a negative over a negative, so that gives me a positive. So I'm just going to leave this blank because it's a positive. And then 58.8 divided by 4.9. And that, too, gives me a nice, easy to work with integer number. Now, look at this expression. This expression looks very nice at this point. It looks exactly like all the other completing the square problems that we've seen up to this point. So we've started with an expression with this s of t is equal to negative 4.9 t squared, blah, blah, blah. That looks pretty complicated because it has decimals. We plugged in 0. We plugged in 0 for this s of t, because we want to know how long it takes the object to hit the ground. And we say that the ground is 0. The position at the bottom is 0. Okay, so we go from this expression that looks very complicated to a nice, easy to work with, completing the square problem. So this is not done yet. Remember, our goal is to actually solve for t, to solve this equation for t by completing the square. Now, let's do that. And I'm going to go to the next slide to make it, to give us a little bit more room to work with. Well, actually, let's not do that. Let's go ahead, take a moment. I want you to try to solve this by completing the square first. Okay, so take this expression that we have constructed from our word problem and see if you can complete the square and solve for t on your own. And when you think that you have the answer, go to the second EduCanon video.